Okay, today's flip is going to be about moles, mass, and Avogadro's number. Before watching this flip, it's very important that you read page 83 of your book, the part about the mole, Avogadro's number, and molar mass. And then later on, after the flip, you're going to go through and do the problems on page 84, 85, 86, and 87. The problems that they're doing in the book here are exactly the same type of problems that we're going to do in the flip today, except the numbers are different. They work them out the exact same way, they follow the exact same steps, and it's really good practice. So if you haven't gone back and read page 83, I want you to do that first and then come back to the flip. Okay, most of you should go back and read, but for those of you who have, we can go ahead and continue. What we're going to do is we're going to do a few types of problems together today. So let me erase my board. And hopefully you are familiar with these conversion factors. These conversion factors are on page 84 of your book, and they were also given in your notes. They show how you take 1 mole of something and use that information to determine the number of atoms or the molar mass, or actually use the molar mass or the number of atoms to find out how many moles you have. These conversion factors are 1. For example, if I had 100 pennies, that would be the same as $1. Even though these numbers are different, these quantities are equal. So when you take $1 and divide by $1, or 100 pennies and divide by 100 pennies, either way, you need to realize that these ratios, just like this ratio, mean 1. And that's really key. All right, let's go ahead and do the first type of problem, which is a very easy, one-step, simple problem. What we're going to do is we're going to take the number of moles in a sample and we're going to convert it to grams. It's a very simple calculation. It's something that's done all the time, and I can't stress how you need to master this because you're going to see it over and over again this semester and next semester. What we're going to use is the element nitrogen. Now, most of the time nitrogen occurs in pairs, but today, just for today, we're going to have nitrogen be just one single little nitrogen. And we're going to start with a given of 3.5 moles of nitrogen. It's really important that when you write a number, you write what you're measuring and what or how you're measuring it, and then what you're measuring it with. So, for example, if you had 3.5 tablespoons of baking soda, you need to be sure that you're very descriptive there. You can't have numbers just sitting by themselves in chemistry. So now we need to figure out how we're going to go from moles to grams. And if we look very closely, we realize that we can use the molar mass in grams along with the moles to get our answer. We'll talk about which one of these we're going to pick in a minute, but first we need to find our molar mass. And if you remember, the molar mass of anything we can find on the periodic table. So, if you go in your book and you find nitrogen, and my cameraman's going to zoom in, if you find nitrogen, you'll see that nitrogen up there, number 7, has 14.0067 grams in 1 mole. That's going to be very handy. We're going to round that down, or just round that off to 14.00. 2 places past the decimal is usually enough. So we have 14.00 grams of nitrogen in 1 mole of nitrogen. All right? And so we're in business. Now we need to ask ourselves, who goes where? Do we put grams on the bottom? Do we put moles on the bottom? How do we make this happen? How do we make this work? When we draw our tracks, what we need to realize is we need to cancel out moles on the bottom. We need moles to divide out. And what we're looking for is always going to be left on top. So we're going to need moles on the bottom and we're going to need grams on top. And the good news is, if we look at this number, it's already in that format. So what we're going to do is we're going to take this ratio, 14.00 grams of nitrogen. We're going to write 1 mole of nitrogen, so I'm just taking this whole fraction and moving it up there. 1 mole of nitrogen. Now let's take a look at what we've got. We've got a mole of nitrogen on top and a mole of nitrogen on the bottom. Those are going to cancel, and we're left with grams of nitrogen on top. And that's good, because we need to go from moles to grams. Now it's a matter of a quick plug and chug in our calculator. What you're going to do is you're going to type in, I gotta remember what I'm doing here, 3.5 times 14, and you can put in the 2 zeros if you want to, it doesn't matter. And then you're going to get the number 49. And the question is 49 what? 49 grams of nitrogen. So we've taken 3.5 moles and we've converted it to 49 grams. And let's ask ourselves for a second, does that make sense? Well, let's think. If 1 mole has 14 grams and we have 3.5 times that, the number 49 makes pretty decent sense, I would say. Okay, so that's how you go from moles to grams. I'm sure with this on the board, you could probably figure out how to go from grams to moles. And you know what I think would be a really good thing to do is to take our answer from here and see if we can work backwards to get our 3.5 back. So I'm going to erase this conversion factor, and I want you to keep in mind that I just put it up here. Don't have to worry about that. And I'm going to start a new problem now. So we've done moles to grams, now we're going to do grams to moles. Sorry, cameraman. What I'm going to do is I'm going to move this 49 grams here, and this is where we're going to start. 49 grams of nitrogen. We're going to put that on top and draw our railroad track. Now we need to figure out how to make those grams into moles. And once again, we're going to use our mole ratio. This time, though, not our mole ratio, I'm sorry, our molar mass. I said that wrong. Molar mass to mole ratio. I beg your pardon. Mole ratios later. We'll get there. So what we're going to do is we're probably going to have to flip this, because this time we need grams on the bottom and moles on the top. Now, a lot of times what kids will do is they'll leave the units in place or leave the numbers in place and then just flip the units. You can't do that. 14 goes with grams, 1 goes with moles, just like 100 pennies goes, 100 goes with the pennies, and 1 goes with the dollar. You can't flip the numbers around. The numbers stay with the units. So if we're going to bring grams to the bottom, and we need it on the bottom because we have grams here on top, we're going to have to flip this. So we're flipping in our flip. 14 grams of nitrogen equals 1 mole of nitrogen. And now, instead of multiplying by this 14, we're going to divide. Pull back my trusty calculator. 49 divided by 14, and you can add the zeros if you want. We get excuse me if you can't see that, we get 3.5 moles of nitrogen. And that shouldn't surprise you, because that's what we started with. We basically did a backwards and forwards. And I wanted to show you, based on what you're starting with, this is how you're going to arrange your conversion factor, or your molar mass. So 1 always goes with mole, and then the number always goes with grams, the number other than 1. And I think everybody other than hydrogen is going to have a number other than 1. So this is how you go from moles to grams, grams to moles. This is probably the most important thing you need to know in chemistry all semester. You're going to be using it a lot. All right, let's use that big number, 6.02 times 10 to the 23, and do some atomic conversions. All right, here we go. I'm going to erase. Fancy eraser. Okay, here we go. We just finished using this conversion factors, grams to moles. Now we're going to use this number, which is Avogadro's number. By the way, he had nothing to do with this number, Mr. Avogadro. They just named it after him. And what this says is you have 1 mole of something, you're going to have this many atoms. And what this number is 6.02 with 21 zeros after it, a lot. So this is a really, really big number. So that should let you know that atoms are very small, and in order to have 1 mole of something, you need to have a lot of atoms, okay? All right, so what we're going to do is we're going to go from atoms to moles. All right? And so I'm going to give you that we have 9.50 times 10 to the 26 atoms of chlorine. And we need to get to moles. In this case, we don't even need the periodic table. We don't need to find our molar mass. All we need to do is remember this conversion. It's very easy. Now, we have atoms on the top, so we need to ask ourselves what needs to go on the bottom here. If atoms are on the top and we need to divide them out, we'll need them on the bottom here. That's going to leave moles on the top. Are moles what we're looking for? Yeah, absolutely. So that's going to work out pretty well for us. So what we're going to do is use this conversion factor right here. And if I was really good, I'd put Cl there, and I will. And then 1 mole of chlorine equals, and you'll have more paper. I'm going to sort of bring this down here. Now I need to punch this into my calculator. And this looks intimidating, but it's actually quite simple. I'm going to bring the calculator over. Clearing out. Now we're going to type in 9.5, and you don't have to put the 0. And then in order to get that exponent, instead of using this caret key, it's really important that you start entering these correctly in your calculator. You're going to press the second function, which is this key. In some calculators it's blue. Then you're going to press the comma key. It's right above the 7, and a little e should appear on your screen. That little e means times 10 to the. All right? And then you're going to type in 26. That's it. You're not pressing times or 10 or caret or anything. It's fewer keystrokes, and it guarantees an answer that is correct, assuming that you type it incorrect. In other words, the order of operations, the exponents and the multiplication, you won't have to worry about your calculator messing that up. All right, and so now I'm going to divide by Avogadro's number, which is 6.02, and really you should put 6.022. If I was good, I would do that. I think I put that in there. We'll go ahead and put 6.022, and then I press my second function, my EE key, and 23 is the number. Sorry, that's Avogadro's number. And then you press enter. And in this case, you should get a really big number. We got this number as 1577.55, and we can leave it at that. And that's moles of Cl. That's a lot of moles of chlorine, right? That's a lot. And when you talk about sig figs, and we will talk about them soon, we'll realize that we'll need to make this 1580, right? Either way, you'll be okay. And that's moles of chlorine. Now, that's a really big number. But let's look. We have 1,000 times more atoms, right, than in 1 mole. So it would make sense that we would have approximately 1,000 times more than 1 mole. So I think that makes sense. Now, the question is, how do we go from moles to atoms? Well, just like we did last time, except we're going to take this conversion factor and we're going to flip it. And what you can do for practice, and I'm not going to do it here in the flip, you can start with this number of moles, go through this, only flip atoms and moles, your conversion factor, and you're going to wind up with this as an answer. And that's a good thing to go ahead and try on your own as you're following along here. All right, we have one more calculation, and it's the two-stepper. Hold on, there's the phone. Why don't you stare at this for a minute while I turn off the phone?